perfect example. Good. So first I have to start by plugging it in because I need to know what type it is. Because if the answer is 5, then I don't have to do anything. So that's why it will save me a lot of trouble. So what do you think when we plug in 0?
Sin x is 0.
Yes. And the denominator is
0.
0. Very good. So a simple algebraic manipulation solved the problem. Because remember, x approaches 0. If I multiply both sides by pi, even pi x approaches 0. Would you agree? Imagine that this is like an equation. If you multiply both sides by pi, you still get pi x equals 0, right?
Yes.
So why am I discussing this? Is because of this. That's why I want that to also approach 0, like this one is. So this is approaches 0, this is approaches 0, and this is also approaches 0. So then limit as x approaches 0. So for sine x, in the denominator, I need an x. But I cannot fabricate an x in the denominator. But I can multiply top and bottom by x, because this is 1. Any questions so far?
Not yet.
So I can multiply top and bottom by x, right? This is 1, correct?
Yes.
Okay, so I will do the same thing with sine pi x. I need the pi x at the top and the pi x at the denominator because this is 1.
Okay.
It's just a simple algebraic manipulation. So when x approaches 0, where does this go?
1.
Yes. When x approaches 0 or pi x approaches 0, where does this go? Because remember, if it's reversed, it's still the same thing.
Right. So that also goes to 1.
Right. And now I have an x and an x that will simplify. And then the answer is?
1 over pi.
That's it. But you understand, I know it's very tempted to simplify this and this, this and this, and no, please, this is the argument inside a function. This is the argument inside of this function. So don't attempt anything. Yes.
So stupid question. So I got the answer, pi guess. If I get the answer by that guess, don't show that work, is the question wrong? Is the answer, will it be marked wrong?
So if it's 5 points, I can only give 1 without work.
I see. Okay.
Very good question. Anything else? From anything else?
I just have to ask because I'm lost for a second here. How is sine of x over x equal to 1?
Yes. And I wanted to even publicly apologize to you and Caitlin. I should have deleted that Zoom session that I had, and just you were the only two who did not find the correct session. And I'm so sorry because I know you guys never miss class, and I really wanted to send the email, and then somebody asked the question, nobody's fault but mine, and then I forgot to email you the link just to make sure that you're not missing. So my apologies. So that is explained. If you have a minute to watch this, this is very important. So this is a very important type of function. So we showed when we applied to this function, to this limit, actually, we applied L'Hopital's rule and it got 1. So also there is a big theory behind this. So please watch that video. I'm not sure which one is towards the end, the second half or something. So we explain how we get the 1 from the previous notes. Is this okay?
Okay.
Because there is a lot of other explanation on that. Good. Anything else? Do we have other questions? In that case, I'm going to share my screen. You can stop me if you remember something. That's fine too. Anytime I can stop. So we're going back to 3.4. And we want to practice a little bit more of the chain rule. So this is a very good example. This is again a good example because we have not really looked at rational functions. Anything you'd like to pick, and after you pick this, I'll come back for a second. Give me 1 second. So the equation of the tangent, I think we know how to do this now, but we can pick a problem from there too, of course. And if you have any questions about these graphs, we can do that too. Okay, I just wanted to browse through a little bit to see if there is anything else interesting here. Because they change some examples, some problems every now and then. I have no idea what they come up with, so I was just curious. Okay. Which one? I couldn't hear.
36.
36 it is. Very good. Excellent. So it's u of y, and that is y to the 4th plus 1 divided by y squared plus 1 and everything raised to power 5. Okay. So it's a good example for the chain rule. So let's work on this. So u prime of y will be, can anyone get us started, or anyone wants to say anything?
You pull the 5 up front and then subtract 1 from the exponent.
Y to the 4th plus 1, y squared plus 1, excellent 4, times the inner function prime. So perfectly differentiated the outer function, and then now the inner function. So I'm differentiating this. How do I start?
4y cubed.
Yes, 4y cubed times the denominator. Excellent, very good. Minus
2y.
yes, you can put 2y in first if you want. That's fine. We can twist that.
2y times y4 plus 1.
That's it. Awesome. Over the denominator squared. Awesome. Great job. Thank you. And no, I don't want you to miss class. Now I know you watched the videos. Thank you. Again, my apologies about that snafu with that Zoom session. I'm so sorry. I should have deleted it after we finished, so my fault. Okay, so obviously I do like to factor. I don't like just simply multiplying and doing it by brute force. So I'm going to copy 5. I'm going to copy y to the 4th plus 1 to the 4th power. Look here. This is to the 4th times another one squared. So I have y squared plus 1 to the 6th power. This is to the 4th, and this is squared. Copy the base, add the exponents for the denominator. The numerator stays with power 4. And now, see here? So I'm going to factor out 2y. So times 2y. And let's see what is left. So 2y is out. So I have 2y squared left. Let me write it. Maybe it's better to write it so everyone can see it. So I have a 2y squared and times y squared plus 1. I'm gonna write this out. Minus y to the 4th minus 1. Because I'm trying to simplify as much as possible. I don't know what I would do if they run out of whiteout. Okay. So again, I pulled out the 2y, so minus y to the 4th and minus 1. I pulled out the 2y, so I have a 2y squared in front and then y squared plus 1. This will move in front now. So we have 10y, y to the 4th plus 1 to the 4th. The denominator will still be y squared plus 1 to the 6th. And 2y to the fourth minus y to the fourth is 3. I'm sorry. See, I'm trying to do too many steps at once, and I shouldn't. So 2y to the fourth minus y to the fourth is y to the fourth. And then plus 2y squared, and then minus 1. And this is it. No one can further simplify this. This is not y squared plus 1 or minus 1 because this is negative. So you cannot factor this. So this is it. That's the final form. And we use the chain rule. Okay. Any questions on this? Okay, so let's go back. And let's look at something else. If you want to choose something else, please feel free. If not, I will.
48.
48. Good pick. So I'm on page 2. Let me copy 48. In 48 we have y equals 2 raised to power 3, which is raised to power 4, which is raised to power x. Great job. Okay. So a reminder for you, when we differentiate a to x, we get a to x times natural log a. So far so good? We have to take it very slowly. See, these are my preps. Okay. So I have y, which is 2, to a function. How do I differentiate 2 to a function? Now, let me also edit this here. So a to a function now, not just plain x. Can anyone come up with a conclusion? A to a function.
Would it be a to a function times ln of a to a function?
Times the inner function prime. Very good. So a to a function, so here it should have been times x prime. But how come that I don't write x prime here?
Because that equals 1.
Because that equals 1. It's not a mistake to write it, but then you have to write it again with 1. So if this is a function, then this will be a function, and this will be the function prime. So coming back to our example. Again, cover it so we can talk about it. So 2 to a function prime. 2 to a function prime is 2 to that function times natural log 2 times the function prime. This is exactly what I'm going to write first. So 2 to whatever, I'm going to write it, times natural log 2 times that prime. So now I'm going to copy it. So 2 to 3 to 4 to x. 3 to 4 to x. So one more time. 2 to a function prime is 2 to the function times natural log 2 times the function prime. Good, moving on. That's not done. So y prime, again, I'm going to write, I can continue there. So 2 raised to 3 raised to 4 raised to x times natural log 2 times, where is my prop? Right here. I'm differentiating now 3 to a function. How do I differentiate 3 to a function? What do I have to write?
You do 3 to
Whatever. Yes. Yes. Times.
ln of 3.
Yes. Times.
Times the
Whatever prime. Excellent. That's it. Now I uncover it. So it must be 4 to the x. It must be 4 to the x. One more step. So I'm going to put this next to this and the two. It doesn't really matter. I can't do anything. It's all a product. So there is nothing I can do here. But Let me write it in some order. So 2 to 3 to 4 to x times 3 to 4 to x times natural log 2 times natural log 3. Now, this is that. There is no more function. There is, but it's x. So how do I differentiate 4 to x?
Would it be 4 to the x ln 4?
That's it. Awesome. Great job. Thank you. So now, again, I'm going to write it again with these 3 at the end. So 2 to 3 to 4 to x, 3 to 4 to x, 4 to x, natural log 2, natural log 3, natural log 4. Not a nice function. But we needed to see it. So it's a very good pick. But again, this is the key because it's very confusing. So the key is cover it and think in terms of the formula you're using. And then uncover and copy it. And then cover again. Oh, I'm working on this. So then I get this. And now there is no need to cover because that's a basic function. Well done. Thank you for your help. Okay, anything else?
And I think it's 46.
46. Very good. Let's look at 46 and then can move on. Let me copy it. So it's y equals the square root of x plus the square root of x plus the square root of x. Perfect. Good pick. I'm differentiating a square root. How do I do that? It's a square root of a function. Let me stop my